It pleases me.
It's almost like we've been doing this before.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm managing editor Tom Nardi.
This is episode 178. This week we'll be talking the return of Supercon, a victory for open source, exquisite timepieces, and documentation to die for. In the news this week, we have the big reveal. The Hackaday Supercon is on. That is 2022 in Pasadena in November, specifically November 4th, 5th, and 6th. We'll be doing Supercon again.
I am very, very excited. I mean, Remoticon was cool. I think we all enjoyed that. There's no replacement for actually being able to do this stuff in person and seeing everybody and just getting together. I think it's going to be big. I think it's going to be a big Supercon. I think there's going to be a lot of people who were kind of, dormant for the last 2 years and are looking to come back out.
Yeah, well, don't say big just yet. We're still looking at how big we can make this. And
that's true, right?
And one of the constraints is, of course, how much space we have to allow to get us compliant with COVID restrictions. So, I mean, truth be told, Supercon's always been kind of, I don't know what, cozy? Like 512 people has been the number before.
Cozy is a word I might use.
I mean,
wouldn't be the first one, perhaps, but it would work.
It's a big cozy. Like, it's a lot of people, but it's not, like, completely ridiculous. Like, when you go to, DEF CON or something where it's, like, 10,000 people.
No.
This is a lot smaller than that. And I think that's part of it. What I really love about it is that you kind of can get to know most of the people there. And I think that's super special, actually. If you've never done a Supercon, we usually set up this like hacker alley outside, and that is going to be really easy to retain unconstricted. We've got balconies and a new space up at the supply frame headquarters that we can use. So in a way, we've got a lot more space to use, and a lot of it's outside. So, should be fairly easy, COVID conformity wise. So we'll see how that goes. But if you're wondering why we're so late in announcing it this year, well, like, duh.
But that's a good point. I do largely think of it as kind of like an outside thing. All of my best memories from Supercon have been outside, in the alley and stuff. So
yeah, right.
That is definitely one bonus.
Yeah, no, some of the talks I can still remember really super fondly. And it's funny, I was actually had to write up the announcement post for this, and I was just going back through 2019 Supercon, and so it was 3 years ago, and it feels like it was 3 years ago. Damn. I miss it, but man, that was so awesome.
Yeah.
Yeah. So super, super, super looking forward to it. Call for proposals is open, so if you would like to give a talk, giving a talk is the best way to attend a conference because you get to talk a little bit about your work, and then everybody else who's there knows what you're into and can talk to you about it later. It's like the ultimate icebreaker in a way, is to give a talk. Plus you get in free, plus
yeah, can't beat that.
You get to hang out in the green room with the cool kids.
free tacos.
Free bottled water. This year we're doing 2 tracks of talks. We're going to do a round of shorter talks, so 20-minute talks in the smaller design lab stage, and then 45-minute talks, our normal length, on the big stage. And depending on how things work, we'll have room for questions in there, and we're just going to have to see how the schedule works. But what that means is that if you've got a kind of smaller project hack idea that you want to talk about, you can absolutely feel free to go give it in the 20-minute talks series over on that side. And if you've got something that just takes a lot more time, it's just more expansive, it's a huge project, then you can present it on the big stage. And I think that's awesome because I remember seeing a bunch of really great short talks over in the design lab. And it's really fun because it gives people, the chance to talk about something that they probably wouldn't talk about if they had to fill up, the really big stage, but they can do it in a smaller venue, I guess, a little bit. that's really awesome because A, it puts a little bit of a time constraint on people and it makes them like really focus. And B, it brings people who are like super passionate about that one topic. And so some of those talks are actually really cool to see.
Well, even aside from the talks, one of the coolest things I thought about Supercon was it seems like everybody has brought something with them, even if it's not like an organized talk. I
Oh,
mean,
yeah.
there were so many people that just pulled something out of their pocket and was like, "Hey, look at this thing, look at this thing I made." And so
Yeah.
even if you don't have like a presentation prepared, if you've been working on something and you can bring it on your person, I promise you there'll be somebody there interested to look at it and talk to you about it.
Oh, absolutely. We usually start off kind of mellow on Fridays with, mid-afternoon, like just after lunch, kind of pre-registration. Everybody can get their badges and start badge hacking. We'll usually run like 1 or 2 workshops, kind of low key that afternoon, but basically just chill out, have a party, everybody start working on the badges, get to know each other. We'll do a bring a hack there. So if you want to show something off, you can. Like we kind of ease into the Supercon.
Yeah, no pressure.
And then Saturday, Sunday is, boom, full track of talks, full track of workshops, tacos, good food. It's the real deal. Then it's game on. Oh, and then Sunday, of course, we close out with the Hackaday Prize winner ceremony and the badge hacking presentation, which is always awesome. You get to see everything that everybody has been working on for the past 2 days. And that is usually really fantastic fun. So definitely, if you can make it to SuperCon, if you think you would want to go to like Hackaday embodied in the real world, you should absolutely go. And speaking of the Hackaday Prize, on Sunday, in 2 days, if you're listening to this as it came out, marks the end of the third challenge round, the Hack It Back challenge round in the Hackaday Prize. So if you've got a project where you are saving old gear from the dumpster by hacking it or revitalizing it, put it in there, because starting up Sunday afternoon, we enter challenge round 4, which is climate resilient communities. And this one's really interesting. The idea is that in times of weather catastrophes or other kind of emergencies, often you have to kind of rely on hackers to keep things going. And so think about communication networks, distributed communication networks.
Yeah, I think this is a really interesting one. We were talking a little bit before we started recording, what some examples of this kind of thing is, and I was reminded last week I did the kind of the recap of the Hack Chat, and Dan was talking to the Amateur Radio Digital Communications Group, ARDC, and they kind of support these initiatives to develop radio and digital communications. And one of the grants they did was for a network to help communications during wildfires and that kind of thing, so they can, not only just have like the sensors out there, but also be able to speak to each other, right? If the traditional network goes down, so that kind of thing would all be part of that.
Yeah, exactly. And speaking of sensors, that's the other part of this one is kind of, environmental sensing toolkits. If you want to develop a network of distributed air quality sensors or something, that would be a perfect entry in this level of the contest. So it's kind of anything that is distributed helps the community either notice problems with the environment or handle kind of climate catastrophes without collapsing.
Right, and we've seen a lot of distributed environmental monitors in previous years too. So I mean, it's definitely as we're recording this, it is extremely hot right now, and likely to only get hotter.
Right.
So as climate change really sets in, these kind of things are going to become more and more important to have these distributed networks to see what's going on and collect the data we need.
And this challenge round also finally gives you people who are interested in messing around with radio stuff, long range, maybe mesh network stuff. This gives you your chance to shine.
This is a journey into sound.
What's that sound?
What's that sound?
Boy, I picked a hard one last week.
Yeah, I listened to this. I think I was doing the dishes or something when I was playing the podcast in the background, and the sound came on, and I gotta say I was freaked out. I thought it was some kind of Lovecraftian creature coming from the drain. It sounded like underwater monsters, and I couldn't even imagine any kind of earthly source.
That's fantastic. Yeah, I loved Christina's answer that it was steel drums being played underwater.
Yeah, there was definitely an underwater feel. Like
There was. Yeah.
something underwater that belongs down there.
Yeah, so full disclosure, this is a music piece called I'm Sitting in a Room by Alvin Lucier.
I am sitting in a room.
And it's really cool from a technical perspective because what he does is he records him saying this phrase, right? I'm sitting in a room recording the sound of my voice, something, something, something. And he's recording it into a microphone and onto tape and playing it on a speaker that is on the other side of the room.
I am sitting in a room.
And so then that records back into the microphone that's sitting at his position. And then it plays again. And then it records back and plays again. And so it's that kind of this continual looping. And every time it picks up a little bit more room ambiance. And by the end of it, after it's looped like 50 times or something, all that's left is like this like echo of the room. And so everybody who guessed these things, like something underwater, or Bill's guess was street sounds recorded through a microphone mounted inside a PVC pipe. That's probably actually
okay. Wow, that's very specific.
pretty close too. Mel mentioned the sea organ. That's another thing with that kind of crazy pipe resonance. It's not the resonance of a pipe. In this case, it's the resonance of the room that he's in, and he just keeps like re-recording it and re-recording it. Unfortunately, we have a winner this week. We got one person who guessed it right. Exactly one person whose answer is I'm sitting in a room recording the sound of my voice, blah, 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 blah. Unfortunately, the nickname of this person is I already won last week. I just want to play along. Ba-doom, boom. So congratulations to I already won. Good job. You are this week's sole winner and only fan of Alvin Lucier in the whole house here. Anyway, I promise I will come back next week with something that is a lot solvable. But until then, go give I'm Sitting in a Room a listen. If you plug that phrase into YouTube, you will definitely find the video. And I know people have done more recent versions of this where they'll like record a video and upload it to YouTube and then download it and upload it to YouTube. And every time YouTube re-encodes it a little bit. And so if you do this enough, it also destroys it. And it's a really neat kind of, I don't know what, long-term distributed feedback loop or something. Trippy. All right, well, my first hack this week is the news that the Ortur laser will probably go open source. And this is an interesting follow-up to an article that came out last week. Watch out for laser cutter manufacturers violating the GPL. Longtime Hackaday super friend Norbert Heinz, who you probably know his videos on the Homo Faciens channel, got himself an Ortur laser cutter and wanted to modify the source code, but couldn't because all they did was give you a binary blob. And he went poking around and discovered that it was actually running Gerbil or Garble or Gerbil or GRBL as the G-code interpreter on the back end, and that is GPL licensed. And GPL license means if you take the software and you modify it, you have to make the original available and your modifications to the original available to anyone who wants it. And so he asked them a couple times nicely and got "this is a business secret" back. And then he decided to make a video about it and say, look, these guys are not playing by the rules here. You know, that was pretty cool. We wrote that up. You know, it was a little bit of a, hey, they should be better. And then within a day, someone at Ortur got back to Norbert and said, hey, you know, you're right. I'm going to look at what I can do about this. And then before the weekend is over, he apparently had gotten approval to post up their source code. I mean, they're probably going to spend some time cleaning it up, but post it up on GitHub. And that's that. And so, boy, this is the quickest turnaround I've ever seen. Like, it was literally 4 days. I mean, Norbert might have made his video last week sometime. We got to writing it up on Thursday or Friday, and then by Monday there was this complete 180.
This is this is the absolute best case scenario, right? Like, you couldn't ask for more than this. But you can say anything you want. I mean, we still do have to see what happens and see that long term, they're still abiding by the license. It's easy to say, oh, yeah, my bad. We screwed up. We'll fix it. But, let's make sure it does happen. But someone from the company is in the comments and saying, hey, it was never our intention to be against the license. We just trying to figure out how to do it and how to, we got to clean some code up. But that's always like the classic argument, right? Oh, I got to clean the code up.
Yeah.
I'd release it, but I got to clean it up. Like, no one cares. Just put it out there. Like, you can always do a revision later. So we have to see what happens. But it's a very good sign.
I tell you what, I'm on their GitHub right now, and I see Ortur LaserMaster 2 Pro is one of the repos. LaserMaster 1 is the other one. LaserMaster 3 is the other one.
I love it.
Like, I think they're really, like, seriously trying to make good.
And good. That's fantastic. That's what,
Wait. Repository is empty. Hold up. Yep. Celebrating too soon here. They've got them set, but the repositories are empty. LaserMaster 3 has a license and a README.
Is the README get bent?
The license
get bent, nerds.
Yeah, right. Yeah, the license is the GPL. So I think
they got that part.
Yeah, no, and that was that guy Gil from the support. So we'll see. Yeah, I mean,
no, like you said, this is a very, very rapid development. So I mean, I think we can give them more than 48 hours or whatever to get it set up. It's definitely a great sign. They communicated with us. And like I said, they communicated on the page, and they certainly seem like they're trying to do the right thing. And why not? I mean, this is the kind of company that is definitely it's a hobbyist thing, I mean, like, getting good buzz in the hobbyist community is only going to help them, whereas being antagonistic and going against the library could only hurt them, so it's the right move. I hope that we can look at this as an example in the future when we see other companies, because there will be, obviously, there's always somebody that doesn't follow the license, and I hope that we could say, hey, here we go, this is a success story that we can kind of point to going forward and say, the consumer doesn't have to be this person you're working against. When they contact you and say, hey, I'd like the source code, just give it to them, and then you don't have to see you don't have to see a blog post come out on Hackaday saying avoid this company.
And good on Norbert for saying, hey, wait a minute, I want more, and wait a minute, you got to give me more. So good for him for putting the pressure on them a little bit and contacting them and being patient like that. I think we probably should all be doing that whenever we see something where, especially with devices like this, where you want to hack on the device and it's just a matter of firmware/software that's keeping you from doing it. Raise the questions at least. Say, hey, wait.
Segue from hobby laser cutters to definitely not hobby 3D printers. This was a really cool story that I feel like is the dream we all have, right? This is about a, roughly $40,000 Stratasys professional real-time 3D printer, not the kind of hot plastic snot that we have on our desktops. Gregor got a hold of this. I think it says for a song. I don't know if it actually says exactly what, or maybe it was even free. Didn't pay $40,000 for it. That's the main thing. It was dead. It came up with an error and said, hey, I can't change the tool or some kind of issue. So off it goes to the graveyard. So he gets a hold of this thing, and he's looking at it, and he makes an interesting observation in that the chamber lights, LED lights inside the chamber, have started to fail and are all yellowed and crapped out. Because this is a printer that's high enough that has a heated enclosure, not just a heated bed like we're used to. This has a whole hot box. And the box has gotten so hot with so much use that it's actually cooked these LEDs. And then he thinks to himself, he goes, well, wait a minute, there's a little LED kind of light gate thing that determines the tool changing. So he takes everything apart and looks in there, and sure enough, the little LED that lights up and makes, one side of the light switch as cooked. So he puts another infrared SMD LED on there, puts it back together, error message goes away, and that's basically the end of the story, right? He fixes this incredibly high-end machine for the cost of an infrared surface mount LED. We could be so lucky, right? Like that's
Damn.
that's what, it's sort of like some detective work, right? You open the door, you're like, wait a minute, look at all these LEDs cooked. I wonder if there's to make that leap of logic, right? Like maybe there's an LED in the tool path that's doing it. I guess you could say it seems like a hell of a design flaw to me.
Right?
That the heated chamber of this not cheap machine ultimately kills itself. But I guess we don't know. There could have been some abuse in its past. Maybe they had it running too hot or something. There was other things that could have been problems, and he does run down the list, and there's known issues with, wiring getting pulled and certain things that these machines are known for. And the kind of the takeaway in the write-up is that, if you ever see one of these things, maybe grab it because
right.
there's a lot of issues that they could be knocked out of service with that are not hard to fix at all. And, you might just have a success story that you could post on Hackaday.
Yeah, part of the reason that these kind of industrial machines, these, professional machines are more reliable, at least in air quotes, than the hobbyist machines is that they've got all of these sensors that make sure they're working, right? But if any of those sensors go wrong, of course, that's a point of failure, and that's going to make it throw an error code. And that's why I put reliable in air quotes. I have heard this from a number of people who run both hobbyist and professional machines, that the professional machine stops and throws error codes all the time. But that's also because it's stopping when it detects problems that would be so small you might not even notice it on your 3D printer.
Well, it is funny. It did remind me of the filament sensor on the Prusa Mark III. The original one was an optical sensor. I think it was actually kind of like the sort of thing you'd see in a mouse,
Yeah.
and it would actually look at the filament and was able to see it move and stuff like that. And through there, it was able to tell if there was a jam and all this stuff. And on paper, it worked great, but in practice, the little window on the sensor got all crapped up because
dirty.
it's sitting right above the extruder, and there's ground up plastic in it. And they had a lot of problems with them, and they started, after X amount of hours, they had trouble seeing the filament, and it was a real problem because if the firmware couldn't see the filament moving, it said, okay, I'm jammed, and it would just stop the print. You know, so you might say, okay, I got that big print I'm going to work on overnight, and you wake up, and halfway through it decided it was out of filament. So you had people turning off the filament sensor, which defeated the purpose entirely, right? So they ended up changing it out. There's a physical shutter that goes between a light detector, so that instead of that complex imaging sensor, it's a very, very basic part.
But the cool thing about the mouse sensor was that they could learn all sorts of stuff about how fast the filament's going through, and they could look at filament width variation. I mean, they had a whole bunch of great ideas with what to do.
Yeah.
How to push that, but then it bit them.
Well, just like you were saying, you try to make them smarter and smarter, and there is some interesting applications for this increased intelligence in the hardware, but it also can be the Achilles heel because that complex sensor, if too many specks of dust get on it, your whole machine's beat.
All right, you want to talk 3D printing and complex machines. This next video from France, a homemade sewing machine may be the only one. Now, it's not fully 3D printed. In fact, there's a lot of metal parts here where they count. And in the video, France demonstrates how he made them. They're actually mostly simple, although requires having a lathe, I think. Precision parts, always a lathe, right? But this is the first time I've ever seen anyone make a sewing machine from hand.
Yeah.
And that is just crazy. It's actually a particular kind of sewing machine. It makes a chain stitch instead of what we think of as normal sewing machines that make a running stitch. And the difference here is that the chain stitch actually only uses one thread, and the running stitch has a bobbin of thread on the underneath that it uses. So it kind of makes two whatever thread paths going through your thing. And this one makes one that's kind of looped around. And the looping around part is, as far as I'm concerned, the coolest part. There's a lot of really neat custom making and stuff here. But for me, the coolest part is the chain stitch hook and watching it go. And so if you just want to forward to that, you can go to the timestamp 7 minutes and 41 seconds into the video, skip over everything about how he makes it, and at least see how this one part works, because it's absolutely fantastic. It's got a hook that, rotates, and one side of it grabs a loop and widens it, and the other side then lets that loop fall when it goes through, and then it falls and makes a knot because the needle has then punched down through it and back up. And so it's like continually, like essentially just tying knots on the underside of the fabric as the needle pushes through. It's a really fantastic machine to watch it go. And I think actually, if you look at France's YouTube channel, I'd never seen this before, but I went and browsed through a bunch of the other videos. There are a whole bunch of these interesting, mostly 3D printed, but not exclusively 3D printed machines. When I was a kid, I really used to love this book by David Macaulay, The Way Things Work. And it's awesome because he has great drawings of like how a sewing machine works. But it's one thing to do that, and it's another thing to see a video of one, even one doing a simple bit of sewing like this one work. And it's yet another thing to make one yourself. And all of these videos of France's all link to 3D printing files that he's also made available for us all. And so if you're curious about how any of these crazy and interesting mechanical machines work, you can just 3D print it out yourself, and boom, you've got a working model of it. Not a video where somebody explains it to you. You've got the real thing sitting there on your desk, and you can figure out how it works.
Well, yeah, it's funny you mention that, because I've always been kind of fascinated by the sewing machine.
Oh, yeah.
Like, it's always been like, how does it work? Like, it's just like, I get everything above the deck, I guess. But then, like, when a stitch goes under the thing, like, is there a little elf in there that, makes the stitch work? And, now looking at this 3D printed version and watching the video, I still don't understand it, but I have a better visual, that now I at least know that it's my fault that I don't understand it. The information's here. I just can't seem to wrap my mind around it, because it is a wild mechanism under there. And yeah, we don't see a lot of sewing stuff really in general. And I think this kind of speaks to, I know Jenny's written in the past about, the dividing line between like craft and hacking and stuff, and there does seem to be kind of a line in the sand a lot, but why? This is kind of a cool example of how you can merge those two interests. If you're into sewing your own clothes and you're into 3D printing, well, here you go. This is a great way to bridge that divide. I was a little surprised that Christina didn't write this up, because I know she's been on the sewing machine kick, and is responsible for probably the majority of sewing machine articles ever to grace Hackaday, which is what, like 2. It's cool to see these, not the traditional thing we're used to. I like to see that people are branching out at different stuff, and that it's being well received too. And that's the other thing. It wasn't like we got the not a hack comments, the dreaded not a hack, right? Like, people seem to really be interested in it, and yeah, it was just really cool to see. I won't be printing my own sewing machine, but I do appreciate that I live in a world where I have the choice. It's possible. If I need to, I could do it.
Yeah, I think if you think about what machines made the Industrial Revolution possible, it's like the steam engine, the sewing machine, and like an automatic loom were like the really big machines, and they're awesome to look at. Like, even just from this is how the dance of gears and wheels and cams move. It's just really fantastic to look at. This one's no exception, but if sewing machines don't tickle your fancy, check out some of France's other videos, because he's got one for you, I'm pretty sure.
Well, speaking of common devices that we take for granted, I really like the way Jenny started her write-up here, called The Casio Smartwatch You Never Had. And she says that, you got to feel bad for Casio for all the incredible stuff that they've produced over the years. if you ask the average person, I guess it'd be like a wash between cheap calculators and cheap watches is what they're known for, right? Certainly, the Casio F91 is like the iconic digital watch. Like you've seen, you might not know the model number off the top of your head, but like if you look at this picture, you're like, oh yeah, I know this. I know this watch. This is the watch. This is like sketch a digital watch. This is it. This is like the form factor. It's from late '80s, bajillions made. I think we covered it in one of the other articles, like how many of these things have been made. They're very basic. They're very basic. It's as basic as you can get as a watch. But this project, it's called Kepler, I believe, is an attempt to create a new circuit board and OLED display that will fit inside the original case and turn the lowliest of lowly digital watches into, well, a lowly smartwatch. It's not the smartest of smartwatches. You're still going to be firmly in the middle. It's going to be kind of thing that's like tethered to a phone. There's an incredible amount of capabilities in here. It's got Bluetooth, so you can do, notifications from your phone, and it's using the Texas Instruments CC2640 microcontroller, which, it looks like an impressively all-in-one kind of chip, because, there's a picture in the write-up that has, the board, and the chip is pretty much it. It's really just, the microcontroller and some passives and everything. Everything's built in. It sounds like this almost like hit a wall a little bit. This is obviously a very involved project, very detailed, and it seems like the creator, what did I say, Pregware, I believe it's called, is looking for help now. He's got to the point where it's working, but it's been a labor of love, and he could use a little bit of assistance. It says specifically the phone app that would talk to it. It still needs some love. Progress so far has been phenomenal, and just looking at that modern display in this like 80s watch is really trippy.
This was the smallest digital watch they could make back then, right? And fitting your own custom electronics, something more competent in there, is a lot harder. And then of course it leaves you having to write the software.
Yeah, only have to write some software.
A simple matter of software.
But this is a great one to kind of read through the GitLab, because the documentation is really nice. A lot of great pictures of the board through different revisions, the display adapter to get the OLED, and it looks like that classic cheapo OLED that we all have in our parts bin too. The SSD 1306. I got like 40 of them.
Exactly.
But he's adapted to this, so it's not like some crazy custom display either. It's really impressive. There's like a 3D printed frame to hold it in place, and it's all wow. I mean, wow, that's really just wow. And then I love the programming jig that because hey, if you're gonna do this, you might as well go all out, right?
Yeah, this is a tidy hackable watch build, like by any standards. And actually, in that sense, it's really super clever to put it in the F91 frame, because that gets you all the hard parts, right? Like it's a waterproof frame.
And have we said 15-day battery life, which is considerable if you think of how much more processing power has been packed in there. There's nothing to sneeze at 15 days, yeah.
From watches to clocks, my next hack is an impeccably documented word clock in Dutch. This is a project by Martin Pennings, and half of the fun here is the documentation. I mean, it's a really nice word clock design, and you should absolutely go have a look at it. In particular, it's all 3D printed, but he has a dual filament extruder, and so he's able to print one in a kind of transparent filament that he uses as a diffuser, and then the background is all in black filament, so it's light tight, and it makes for a fantastic contrast and evenly illuminated, and it's just marvelous. But what's even more amazing is the README here in his project over on GitHub. He talks about everything about the design of this particular word clock. Because he wants to use an 8x8 matrix of WS2812 LEDs to do it in full color, and because those displays are like $3 each if you buy them on eBay, he's got to limit himself to not 10x10 or 15x15, which even some of them are, but all the way down to 8 by 8. It's really interesting to kind of go through this puzzle of how to pack this many words into an 8 by 8 matrix. And he does it by cheating sometimes. Sometimes it goes diagonally. Sometimes I think he has the I and the J together in one pixel, so that in Dutch it must be VIJF, which is 5, is the I and the J. He's squished them together. But he doesn't cheat very much. And the end project is absolutely marvelous. It goes through completely documenting the power draw of the LED matrix to the different ways you could possibly work on getting this layout done, to what you want to use as your time source, whether you want to use NTP or whatever else. He's got slight modifications that he makes to the ESP8266 board. I mean, there's just a lot of detail here. And if you want to make yourself a word clock, maybe not in Dutch, this is still a fantastic resource for you. You just have to work on figuring out the 8 by 8 layout by yourself.
I'm looking through it, real time.
Yeah, keep scrolling.
This is preposterous.
Keep scrolling.
In the best way possible. Like, this is maybe some of the best documentation I have ever seen on a project we've covered. I mean, and that's not even like an exaggeration. I mean, this is incredible. The pictures are phenomenal. I mean, he's even zooming in. I wonder, is this what he does for a living? Is he like a professional technical writer maybe? And like, hey, you know what I'll do for fun today?
Maybe.
I'll write up my my little project. But yeah, this is wow. This is really, really great stuff. This is, to me, like one of the great things I think about Hackaday is that I'd never be looking up a Dutch word clock, right? Like I would never go out of my way to find that for many reasons. So this is something that would be utterly invisible to me otherwise. But, because it's up there, and I still don't need a Dutch word clock, but I'm reading it, and I'm looking at this documentation, and there's absolutely something you're going to learn. You're going to read this and you're going to learn something new, or you're going to pick up some kind of trick, and you're going to be able to apply it to something else. Maybe it'll be word clock, maybe it'll be something else, but like you can't look at some documentation this detailed and not come away with something new in your head.
True that. Well, I tell you what, if that word clock is not amazingly well documented enough for you, I'll throw yet another in. You don't need a word clock in Dutch. You probably don't need one in German either. But I'll throw you the link to a German website. This is over at microcontroller.net. And this is a German website where they do a bunch of crazy microcontroller hacks. And the word clock project was probably the most popular one ever. It was like hundreds of forum pages before it got condensed and spun off into a new one that's only 30-something forum pages. Anyway, you should check this project out. I've put the links in the show notes. You'll probably want to look at it in translation. This one has so many different options. It uses a blue pill board, but you can add on a real-time clock. You can make it drive WS2812s. You can add on a temperature sensor so that it tells you the temperature. It'll take one of those DF robot DF players that plays sound files pretty easily, so you can have it be a speaking clock. It's got a provision for a light-dependent resistor, so you can have it dim itself. It's got I guess it's the German radio clock, so it can set itself by the equivalent of WWV here. It's DCF77. It's got an ESP8266 web module that then is like configurable 17,000 ways from Sunday. And to make matters worse, Germans and Swiss and Austrians all speak German, but they speak different Germans. And one of the things that's really weird is that they all have different kind of traditional ways of telling time. And so it's got all of these different versions in it. And so whereas one would say, it's 15 minutes before 3, the other would say it's 2:45, and so on and so forth. And so you can set it to your particular word clock favorite language version as well. There's something about word clocks where it's like the perfect project to like just go over the top and, every project needs to be able to be set by an infrared remote, right? Well, this word
Yeah,
clock
right.
can as well. You know, it's one of these projects that just invites everybody to glom their bits on if they want to. And I think that makes it a super interesting beginner project, but also an advanced project too, because you can kind of show off. Like this one of Martin's is so refined and so kind of, it really only does what it does. It's not overly fancy. It really just does the right things, you know, pulls time over NTP. Simple solution. So you can go as crazy and, you know, extravagant as you want, or you can focus it down. And then when you feel like adding something crazy to it, you could do that too. That's just a great, super easy, potentially super easy beginner project that then you can refine as you get better.
I just saw the replication part where he made one for his friend or something,
Yeah.
and then documented the changes for the second one. Like, who does that? Like, that's so great. Like, of course, the second one you're gonna learn the mistakes, right? So he even went there and said, you know what? If I was gonna do it a third time,
That's the
it
best
would look
part.
like this.
That's the best
wow.
part.
Wow, awesome.
Secret confession time. I don't have a word clock. Reading this all makes me want to make one.
Well, I picked this last one kind of in a similar vein. I was just blown away by the documentation that Green Luigi 1 put together for this. Write-up's called Hacker Liberates Hyundai Head Unit Writes Custom Apps. And as you might have guessed from the title, Green Luigi got I think a 2021 Hyundai. Very new. It's, you know, this is not some decades-old head unit. This is about as new and shiny as it gets. And it runs Linux, which is cool. Right off the bat, I was kind of surprised. I kind of thought everybody had switched over to Android and that kind of stuff. But this actually is running their own in-house Linux. And he set out to crack into it and ultimately figure out how to run custom apps. You know, it sounds kind of weird, but I think my favorite part about this was how much time was wasted. Because if you read it, you know, it's a phenomenal write-up. It's kind of written as if you're like over their shoulder, right? Like you're right there with them, following step by step, and it's very engrossing. It's almost like I'm reading a novel or something about how to crack into your head unit. And you know, go through all the steps and all the process. And in several cases, after going on and on and on about these things he was trying and attempting, he'll say, you know, but then in the end, I didn't need to do that. And then this is the way it ended up working. And, you know, some people might look at that and say, well, that's just a waste. You know, that's a waste. Why bother writing all that up? But, like, there's so much fascinating stuff in here that was tried. And, okay, sure, in the end, it was unnecessary for this particular situation. But, like, you could use this other ways and in other projects. You know, off the top of my head, there's a big part of when he was getting started, the update images come as zip files that have passwords on them. So it went through all these different kind of ways to try to crack the passwords, and it goes down this whole, you know, there's like the usual password brute force stuff, and that didn't work. And then there's this whole other kind of segue where there's some exploit in zip where if you can get one of the uncompressed files that you know is in the zip and give it to this tool, it can then figure out how to, you know what I mean? It uses that as like an example. He was going through and he looked at other firmware images with the idea that, okay, you know, these things probably have a lot of commonality and they're based on Linux, so there's got to be some kind of little weird Linux config file I can pull out of these other ones that would be the same. So he does a lot of that. It goes on and on looking for these files, and he finally finds it, and that doesn't work. And they're just, the long story short, and it is a long story, he finally goes back to like the very beginning where he was able to download some of like the source and toolchain stuff from Hyundai. It sounded like they actually did good on them, actually offered some of this stuff because it's, you know, again, GPL, right? And there was a bash script in there that I guess is used to create the firmware updates. And he said, like, when he read the script, it actually had the password
includes
right in
the
there.
Key.
It was right in there. So he spent all this time trying to crack it, only to find out. And he literally says, like, it was on my hard drive the entire time. But you know, but good on him for still writing that up and still including the screenshots and still saying, hey, and he even says at one point, you know, I screwed up the command options. I did it wrong. You know, he doesn't pretend. Like he said, I did it wrong. I was giving it the wrong switches.
Yep.
Because that's how we learn, and that's how someone else is going to find this, and they're going to see that, and they're going to, you know, in their case, it might work, right? Like that might have been the thing they were looking for, that you know, needle in a haystack. He does crack into it, and it's basically a normal Linux system for the most part. He uses Qt for the graphical stuff, so he shows how to whip up a simple program, and like the final shot is his little name, hacked by Green Luigi, and some little button. So now he has complete control over the head unit, and this is like where things really get interesting, right? And I'd love to see, we've seen this before. People are like, "Oh, I finally cracked into my head unit, and I can write apps," and then like, well, what did you do with it? Like I really want to come back and see in a few months or a year or whatever. Like, what did you do with it? Did you come up with something cool, or was it just conquering another device because it was in front of you?
I'm cool with either of those, frankly.
Yeah, true. Yeah, I should be clear. If that's it, no,
That's
no
awesome
judgment from us.
Yeah.
But I'd love to see somebody like really, go all out and have this customized UI and all kinds of cool little things.
Absolutely. No, and I think you absolutely hammered it about how watching him make these mistakes is not the right word, but watching him like go down these dead ends and then come back out and be like, "Oh, that didn't work. Try this. Well, that didn't work. Try this." It's one of the first really honest how I hacked this device things I've seen in a while. And, in my mind, there's kind of this spectrum from like, how Hollywood does hacker things where the guy just like, there's a music montage and he puts on his hacker gloves and he flips his hands on the keyboard until he, gets the password out in 28 seconds versus this on the other extreme where he's like, oh. And then I tried to like do this known plain text attack and I did this and I did this and then it didn't work because the known plain text is on how the file should be zipped. How it's zipped unencrypted, not how it's in its plain text unzipped format. This is the real deal here, folks. And you're right. It's totally like looking over his shoulder. It's totally like seeing a real hacker do it. And yeah, that's different from, watching over Tom Cruise's shoulder as he goes flippy flippy with his hands on the keyboard. And also gives you a feeling for kind of the, how much actual pain there has to be when you're doing one of these devices. Like sometimes you get lucky and the easy thing works first off, but a lot of the time you try the easy thing and that doesn't work. And then you try the next easy thing and that doesn't work. And then you try the next easy thing and the next and the next. And so it's good to see that happening too.
I think that you use the perfect word, honesty. This is very honest. Not everybody could do that. You have to really kind of put your ego to the side because there's several points in here where he's like, I don't know. Or just like, I did it wrong, or I thought I could do it this way, and I bit off more than I could chew. It's very real, and it didn't work this time, but maybe he will personally, in the future, he'll go back to his old thing, and instead of, not documenting it for the sake of his own ego, he's like, oh yeah, that's what I did wrong last time, and boom, and he'll be there. So it's, you're helping others and maybe yourself, too.
Cool. Quick hacks? My first quick hack this week is Programmable Resistance Box by Eastwood Tech. This is actually a Kickstarter for a resistance switcher box, except this one, instead of being activated by turning a bunch of dials that select among different resistors, uses a bunch of relays and a microcontroller. So you can plug it in by USB, tell it you need 1,237 ohms, and it goes click, 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 and it gives it to you. It's really cool because it combines both the digital in that it can be easily calibrated to make kind of arbitrarily precise values by selecting among the resistors it has, with the physical. Whatever your signal is, it's running through physical resistors here. Next up, Robot Arm Has the Touch. This is a project by Maurizio. It's a pretty simple, in air quotes, robot arm. It's basically run by kind of over-the-counter servo motors. It's nicely built, though. It's got a bunch of 3D printed parts and aluminum square tubing holding it together. So it's probably a little bit stronger than the average wobbly arm. The other thing that I really like about this is that it's all controllable by App Inventor on your phone. So if you've struggled to think about how to make an application for a cell phone simply, this is kind of your reminder to go check out App Inventor again. And last up, on the totally other extreme, down the Intel microcode rabbit hole with Mark Ermolov, Maxim Goryatsky, and Dmitry Skylarov. If these names are familiar to you, you will know them as the people who cracked into the Intel management engine. Here they are enabling kind of a debug mode on certain Intel Atom system on a chip systems that puts it in you can play around with and dump the microcode mode. This really doesn't belong in quick hacks, but this talk is so involved, we could spend the whole podcast talking about it. So I'm just going to say, if you're interested in microcode, the computer that's running inside the CPU that you can't see, that translates what you think of as machine code to how it actually works, this is the talk for you.
All right, my first quick hack is Washington, D.C. finally gets its own PCB metro map. This is a project, to be fair, we've seen several times at this point, but I never get tired of them. It's a circuit board that has been designed in such a way that it replicates the transit map of, in this case, Washington, D.C. And there's little RGB LEDs dotted everywhere that represent stations, and, it's got an ESP that pulls down the API from the actual transit authority in Washington, and the lights will light up as the train's moving, kind of like a little snake game. And it's just really cool to see. I wish I had a good enough transit system in my own hometown that I could put something together like this. But it is cool to see people running with this theme and documenting more and more cities in PCBs. Next up is porting Doom, but in the opposite direction. Doom is kind of the quintessential, can it run thing, right? We see Doom get ported over to anything. If it can run code, it's going to be running Doom at some point. This is, like the title says, sort of the reverse. There was, you might say, like the lost Doom game. In early 2000s, someone had the great idea to make a Doom RPG for early, we're talking pre-smartphone here, so your flip phone would run this really janky Doom game, and because it couldn't do it real time, the control, didn't have enough controls and all that kind of stuff. It is a turn-based shooter, and it never was released anything else because, frankly, why would you play it on anything else? I am sure there is a group of people out there who are salivating now over the possibility that they could take this once phone limited Doom RPG and now run it on their desktop machines. And then my last one is peer into space through this James Webb style hexagonal mirror. We've seen a lot of interest in the James Webb Space Telescope, right? For good reason. And it's kind of an interesting thing that it's taken the form in a lot of these artistic pieces where I guess at this point we could say iconic look of the main mirror with its little hexagonal gold tiles. And it's helped by the fact that apparently you can get these little gold hexagons on Amazon, so you don't have to make them yourself. In this case, it is one of these wall pieces where Frederick got these Amazon little gold hexagons and made the shape of the main James Webb mirror. But in the middle, the hexagon is missing, and there's a screen back there hooked up to a Raspberry Pi, and it's showing images from the telescope. Or, well, it will in the future. Right now, it looks like it's kind of pulling from a static collection, but he says that once the online source for this kind of stuff is solidified, which NASA's really good about, it'll pull down like the latest image and show it. So it's a really cool piece of wall art. Even without the display, I would be happy to have it, but adding that display and adding that interactivity kind of takes it to the next level, and I would not be surprised if we start seeing copycats of this particular layout.
All right, now it's time for our Can't Miss articles. These are long-form articles written by our own Hackaday writers. This week I'm picking Al Williams's Tech in Plain Sight Fire Hydrants. And I picked this one because I learned a lot by reading it. And so I'm just going to have to summarize all the crazy cool stuff that I learned about fire hydrants for you right now. One is that they're called fire plugs because back in the old days, they used to just drill into the wooden water pipes to get water out to extinguish a fire. And then after the fact, they would plug it up. And that's why fire hydrants are sometimes called fire plugs. And I guess it didn't take much after that experience to be like, hey, wait a minute. If we know where these holes are in the water line, we can just unplug them later when there's a fire and use it. And then it doesn't take long to say, oh, wait, if we just put a valve on this, then we would have what we know and love today as a fire hydrant. And that's what they're about. I thought that was, I don't know, history of the fire hydrant? Who knew? But then there's a bunch of other variations on the fire hydrant. If you think about it, it's like, I'm American. I came from this, like, all of our fire hydrants look exactly like the fire hydrant in the picture. And there's this global, tremendous variation in fire hydrants. All the fire hydrants in Germany look the same too, but it's totally different from the American fire hydrant. In some places, they just have underground fire hydrants. And so it looks like a manhole cover and you pull that out. Boy, that makes a whole lot of sense, doesn't it? Like, you just pull this thing up and connect your hose down there. I mean, anyway, there is a lot to learn about fire hydrants. You know that thing at the top that opens them? It's actually goes way down in most cases to the pipes themselves because you don't want it freezing. And so it's actually turning a valve that's way underground below the frost line so it doesn't freeze up. Let's see, what else did I learn? All sorts of stuff about how they drain. There's actually a phenomenal string of comments on this one with people who've worked for fire departments or cities taking care of their water mains or actual fire companies. And if you want to talk about the things you didn't think about in designing fire hydrants, turns out people have thought through them all. They've run into all the problems and they've solved them all. You should go read the comments on this one too.
Yeah, I think this is one of those ones where my American ignorance was highlighted because it never even occurred to me that there would be different looking.
How could there be a different fire hydrant?
In my mind's eye, I see a fire hydrant. I mean, even like watch some cartoons or see some little kid's toy, they all look the same. Well, that's because they've all been produced, for the country I live in.
Yep.
And then you look at these other ones, and they're wild. Some of the designs, and some of them make a lot of sense. And it is interesting to see, what's developed and why. Like I said, the history of the fire hydrant would have definitely been a cool alternate title. I think perhaps my favorite part was that he says that the original patent for the 1801 hydrant is lost because the patent office burned down in 1836. So, a little fun irony there. I love this Japanese one too. Like, that can't be like an official artwork, right?
It is. And I was
looking.
I was looking for more photos for this. I had to pick the banner image and I went looking and I stumbled on, like, they have that same kind of logo in round ones.
Wow.
For those of you out there, it's like two happy little anime Japanese firefighters coming out with a hose to, like, put the fire out. And they're, like, running. They've got the, like, little anime sweat pearls coming off of their head because they're freaking firefighters and they're carrying a heavy hose. And
I swear the one in the back is doing the Pikachu face too. He's like a little Pikachu meme, like, oh,
kawaii. Yeah, dude, it's the cutest fire hydrant you've ever seen in your life. And it's real. And if you go looking these up, there's like hundreds of these pictures because every American who's ever walking around Tokyo is like, no way. Yeah, and they take a picture of it.
They look surprisingly like samurais too.
Yeah,
that's
dude.
Awesome.
Yeah, that's something he doesn't get into in this. But speaking of shocks to you as an American, we all know what a fire helmet looks like, right? German fire helmets are totally different. I'll have to find a picture of a German fire helmet, but you show a German person a German fire helmet, and they're like, oh yeah, fire helmet. It's exactly as iconic for Germans as ours is for us, and they're totally different. And I had some kid's book in English, and I was showing it to my son, and it had a fireman, and he's like, what is that crazy hat that dude has on? And I'm like, yeah, fireman's hat. So I don't think these are samurai hats. I think secretly these are Japanese fireman helmets.
Oh, awesome. No, there's like a lot of cool little details, like you said. I liked one part where he said, the color is important. We always think of them. Well, I shouldn't make generalizations, right?
Yep.
But I would say most of us think of them as red. But he's like, if you ever see a violet one, then that usually means it's non-drinkable water is the setup. Not that you probably should be drinking water from any of the hydrants, but specifically if they're not red, then definitely don't drink those.
Yeah.
Yeah, it's really cool, and he talks about like the dry ones, which are I guess not pressurized, but they are connected to water, right?
Right.
So the fire truck can suck the water out of it, but if you open it, water wouldn't come out. And it sounds like those are something that you'd see around like lakes and that sort of thing.
Yep.
A lot of fascinating little details, and we've been doing these kind of series of posts where you look at something that we kind of take for granted and do a deep dive, and it's just always really fascinating to me. This kind of stuff you never even considered, right?
Yeah, every time I learn something, and damn it, I did this time in spades.
Well, my can't miss article is "Dead Solar Panels Are the Hottest New Recyclables" by Lewin Day, and this is something that I think about a lot, honestly, and I think maybe it's not obvious to everyone. There's this huge boom, and there has been since like the early 2000s. Solar panels everywhere. I mean, in my town, there's literally solar panels on every utility pole. There's little solar farms picking up like solar. Problem is, these things only have rated service life like 25, 30 years. So very soon, within the next couple of years, and more and more, exponentially, we're going to have a lot of dead solar panels. And the question becomes, well, what do you do with them? Okay, you can take the glass off the front, you can take the aluminum frame, you can even cut the wires off the back, but the panel itself is very tricky to recycle because it's all fused together. It's going to be an issue. Lewin says in here, right now with current technology, most of them just end up in the landfill. At least in the U.S., it's 10% recycled, and everything else just gets trashed because nobody wants to deal with it. And we can kind of get away with that now,
Yeah.
But we're not going to be able to get away with that in 2030 and 2040. When the tidal wave of these things, it's not to say they're paperweights. I mean, it's the kind of thing where their energy output starts getting so low that you're going to say, well, what the hell are these things on my roof for?
Time to replace them.
It's time to replace those. So it's not going to be like one day a light bulb burns out, right? Like it's going to be staggered, and some people may say, well, hell, I'll keep holding on to them, but there definitely going to be a lot of them.
Yep.
Definitely will be a lot of them coming into the waste stream within the next decade or so. So there are techniques that are being developed that Lewin talks about here. One is helpfully called full recovery end of life photovoltaic process. Make it easy.
Huh.
And he describes this as like a hot knife that cuts apart the cells, and you have silicon on one side and plastic and glass on the other, and then you can kind of go through the recycling that way. He also talks about a French company that's been doing a commercial scale recycling plant since 2018, and also a new branch, they say, is opening in Germany this year. Well, they first take them apart. They use robots to take the frames off, take the copper wires off, and then they cut the panels into these little, more easily manageable chunks, and then they get ground up, and a eddy current separator is used to pull the metallic parts away from the glass. So that's another approach that seems like it's really working for them. And there'll be more. There's going to be more because there's going to be this huge demand for it, and we're going to see certainly some companies stand to make a lot of money in the next decade or so, coming up with ways to recycle these panels and get the raw materials out of them. And it's going to be like a gold rush for these green companies.
The ones that are doing the separation, I watched the Veolia video through, and they say they split it up into like 10 different bins at the end. And the part that you think is the hard part, like the actual polysilicon part, is probably the least valuable part that comes out of this. Like when they take these panels apart, what they're really after is, all the aluminum in the frame and all the copper that runs around in there in the bus bars and things like that. Like that's where kind of the real money is in these. There's also a lot of cadmium in some of them and silver in others, and like there's a bunch of other metals that they're getting out of this. And at the end of the day, what I think of as being a solar panel kind of naively, which is like the glass and the polysilicon crystal stuff. That's not where the money's at. The money's at like all the other stuff that composes the solar panel. It's like all the other metals and stuff. And so I don't know what to say. I think it's interesting because, like you said, there's going to be this tidal wave of solar panels with reduced capacity that are going to get swapped out for newer ones. But at the same time, we're going to need these metals for making batteries and for, everything else to do with solar and electricity. So it's totally good to get them out of there if you can. And it totally makes sense to recycle them, except maybe not yet economically. And that's the other problem here, is that the panels are cheap and the amount of value they can get out of them is still small in comparison to how much it costs to fetch them and return them. And that may be something eventually like battery recycling is necessary, where you kind of have to pay, or like bottle recycling, where you have to pay a deposit on it and you get that money back when you take it in to get recycled. And, that works for lead acid batteries. If you think about the car battery in your car, you get, $20 back if you take it back to the store when you get a new one, right? And then it gets recycled. And actually, Dan Maloney wrote a piece on that a long time ago. I'll have to find the links and throw them in, about how, like, the reason that 95% of the value in a lead acid battery gets recycled is because there is this system in place. And I think that's something we're going to see in a whole bunch of different industries where, maybe even if it's only break even to recycle your solar cells, it looks like in the future we're going to have to probably put a little bit of a deposit on them so that when they're 25 years old, you can take it in to get recycling and get some of your money back out.
Yeah, I mean, like you said, this is going to be, we've had car batteries for quite some time now, so it's only natural that, a mechanism has been developed where we do the core charge and everything. So yeah, something like that could become standard going forward. Lewin talks about, there's an estimate from a company, research firm, Rystad Energy, that says, the value of the whole solar recycling industry today is $170 million, but that they expect it to be worth almost $3 billion by the end of the decade. Like, that's an insane growth. For 170 million to, they're saying 2.7 billion. That's insane in, a handful of years. So it's coming. Like, there are many people thinking about this right now. And Lewin's also written about similar issues with, the wind turbines. What do you do with the blades when they're, when they can't be used anymore? And I think the important takeaway, although I didn't see much of it this way, like, this is certainly not like an anti-solar article or anything, or anti-wind. Like, no one's saying stop using solar panels because we don't know how to recycle them. What the thrust here is that we got to figure out how to recycle them in the next few years. I guess you could almost say it's a necessary evil right now. In the short term, we'll use these things. We're not 100% sure what we're going to do with them in 25 years, but at least we got 25 years to figure it out for, something installed today. It's not saying that we're making a mistake by doing solar, just that there's still things to be learned and still some stones that need to be overturned.
Yeah, I think it's interesting. You mentioned how solar cells degrade and they kind of just lose their capacity slowly and gracefully. And some people asked about this in the comments. The figure I've seen is that firms, when they tell you a solar panel is good for 20 years, they're aiming at holding on to 80% of its initial rating. And that means these like dead solar cells are really still working at, 4/5 their total output from before. It may make sense economically to then buy a new one and put it up on the roof because, like you said, they pay for themselves, in 5 years or 10 years. So by the time it's 20 years old, it's fully paid itself off and then some. And it might be worth it to you just to get the extra power on a limited amount of roof space to buy a newer model, right? But that doesn't mean that someone somewhere in the world wouldn't be stoked to get a solar panel that's got 80% use. And that's the other alternative to kind of grinding them up and recycling them that's proposed here, is to see if you can repurpose the ones that, have half capacity, have 80% capacity, And so, it's not viable in a place where you're restricted by space, but might be viable in a place where you have like lots and lots and lots of land exposed to good sun. And so there may be another path here that's not grind them up and recycle them, but put them into an alternate use and recycle them. And I'd like to see some of that too. Haven't done the research on it. This is just kind of me spitballing, but I wouldn't be surprised if there's some of that on the side as well.
Well, it's a little bit like, grabbing the old laptop battery pack.
Yeah, it's like me and lithium-ion batteries.
Right.
Hell
Finding
yeah.
the dead cell, and, you replace the one cell, and the rest of them still got, 70% of their life or whatever. I mean, it's not,
Yeah.
that, like you said, they could just be, they get a second life as a lower rated panel or something like that. I wrote an article a little bit ago about the space station. The panels are now, because, the space station was launched, the initial modules in 2000, 2001 or whatever. They're now hitting that limit. They're starting to see that reduction, and up there, it's kind of important, right? You need power. But they're not dead. They're still putting out, like you said, I think they did quote something like 70, 80% of their original power. So rather than disconnecting them and letting them burn up in the atmosphere, they just rolled newer panels over top of them. And they didn't even cover the whole thing because they said, well, we're still getting useful energy out of the old panels. So, we're going to augment it with newer, more efficient panels, but those ones will still keep putting energy into the system, less than they were, 20 years ago, but they're still going to be up there doing some useful work. So, that could also, be a thing where as, the panels get cheaper, maybe you just start adding more to them. You leave the old ones there, you just start adding more to get back to where you were.
Yeah.
And keep playing that game as long as you can.
That's all the time we have for this week's Hackaday podcast. Thanks for listening. If you'd like to write to us, you can reach out editor@hackaday.com. If you see anything cool or do anything cool, shoot us an email, tips@hackaday.com. Links you will find in the show notes over at hackaday.com/podcast. And until next week,
Keep on hacking. Quiet all week until, hey, somebody making a podcast? Time for me to build something.
that's all I can think of.
I think that's good. No, I didn't even realize.
I think we're good on this one. We didn't even plan this, but we did it.
All right, we can stop this, right? We're recording? Okay.